Howdy folks, this video segment is about automatic unloading system, abbreviated as AUS. Basically, AUS are found on oil tankers such as ULCC or VLCC, ultra or very large crude carrier, including some medium-sized transporting product oil and crude oil cargoes called Aframax, Suezmax tankers. They are fitted in part of the ship called pump room, whilst the majority of tankers, product or chemical, which of smaller sizes are using dedicated or individual cargo pumps and piping systems, and has no AUS system. So let's begin by showing you the cargo pump room first. Let's go. Okay, we are entering the pump room or cargo pump room of this ship. So we are on the first level actually, and skipping some pump room deck levels so that we'll get there in no time. And as we are passing through some pipes, bulbs, you'll find here also the so-called ODME or oil discharge monitoring equipment, which is of course the systems, and the consoles are also located in the cargo control room. So we are now on the second to the last level, going down to the pump room area, or where the cargo pumps are located. This is basically in line with the cargo tanks on the bottom of the vessel. So basically, as you can see here, we have the cargo pumps and cargo pumps 1, 2, and 3, and also we have here also ballast pumps, and on the forward part is the stripping pumps. So there you go. Right, I'm just gonna show you a quick close-up, and I will pause in this area. Right, we are viewing or looking at the right side of the pumps, viewing towards the stern or engine bulkhead, and this is the discharge outlet of the pumps. Driving shaft coming down from the deck seal unit, air or gas separator, and lastly, this is the cargo pump, single stage, radial type flow, can be fitted with steam turbine or electrical motor drive system. And this is the full view of all the cargo pumps, 1, 2, and 3 shown in here. To further illustrate it, the pump room is located just in front of the accommodation, separated by a cofferdams between the tanks and engine room bulkheads. Pipes are led out from the foremost tanks, penetrating through other tanks where it is connected with suction bell mouth and runs towards the direction of the pump room. To simplify it, this is how it looks in a schematic diagram using an example of one cargo tank, one cargo pump from one tank with the AUS and associated system. Now, what is the purpose of AUS or automatic unloading system? The purpose of automatic unloading system actually is to reduce the cargo discharge time, and basically also to protect the pumps, which of course when we are talking about net positive suction head, when the available net positive suction head is becoming low, wherein the suction side pressure is lower than the vapor pressure of the tanks, then what happens is that it creates bubble. Now, actually, a centrifugal type of pumps cannot actually discharge the full cargo volume or cargo content of a tank. Eventually, it loses suction, and hence cavitation takes place, and of course, there will be some unpumpable quantity. Thus, the AUS basically optimizes the cargo pumps to its maximum performance before stripping of cargo tanks takes place. Hence, we could say that AUS also reduces stripping time and amount of unpumpable quantities. Let me show you this animation. When the tank is full, the cargo pumps are basically happy. Weight and gravity floods the pipe in full, and so with the cargo pumps. Take note that the centrifugal pumps are not a positive displacement type. Hence, a primer is required to run it. As the liquid goes down, let's say for example about 2 meters, as shown in this animation, the net positive suction head available is getting low further, and with such level, bubbles or gases or air are produced. This condition was created due to the lower pressure in the suction inlet area of the pumps versus the vapor pressure within the cargo tanks. Now, I would like to term the AUS system literally called as a deceiver. Basically, the pump is deceived by the AUS or automatic unloading system, telling the pumps that the cargo tanks is still full, though it's literally just about down to its stripping level. However, in working principles,
The air or gas separator has a liquid level sensor of minimum and maximum. This level signals the control unit, as shown in this diagram. When the separator tank is down to its level, the vacuum pump runs and suck off the bubbles or air, and some liquid may be included. This creates a vacuum within the separator and further fills it up to its optimum level. At the same time, if the AUS processes filling the separator tank is hot up due to high volumes of gases, then the capacity regulating pumps closes or throttle down a bit to build up high suction pressure, helping the separator to be filled up and sometimes minimizing cavitation within the impeller. This goes on and on till as long as the pump is still stable. The gases or air and some liquids are directed to these lap tanks. Eventually, the chief officer may take off the AUS and do the manual throttling of the capacity regulator valves. At a certain point, the cargo pumps, even with the AUS, had just have enough and can no longer pushes further. At this point, the main discharge of liquid from the cargo pumps is stopped and the stripping pumps gets into the picture.
Alright folks, sa final recapitulations of this lecture. So in this schematic diagram, as you can see here, we have the, of course, the line coming from the cargo tanks. This one, this is your from tanks, and of course the other line, of course, is for the ballast. This regardless, right? And we can see all here that we have 4 main cargo pumps. This one, of course, this one. This one, and of course this one as well, and the number 4. The rest of the other 3 pumps or 4 pumps are the stripping pumps and the ballast pumps, which we just disregard. And of course, as I mentioned earlier, the centrifugal pump with regards to very large crude carrier or even larger like ultra large crude carrier, that kind of pumps, if they have a pump room, they cannot actually remove all the cargoes down to its draining level. In most cases, eventually it loses suction, and of course I have already mentioned the reason why. And so the AUS will of course come into the picture, and of course as you can see here in the diagram. So as you can see, when the tank is full, the centrifugal pumps are quite active because of the weight and the gravity of the cargo. But when it gets down to its level, of course it loses suction, and the net positive suction head available is becoming lower and lower, as I mentioned earlier. There are cases, of course, that the chief officer of course will do it manually because they can actually feel it, how the pumps behave at the same time. Sometimes there are also differences wherein a computer is actually monitoring compared to a human doing the control. So in this case, controlling the so-called regulating discharge valve is also important, especially when your pumps are old and your systems are old or ships. In most cases, the performance of the system is somewhat deteriorated already. So as I mentioned in the earlier discussion, that I mentioned that I termed it as a deceiver because as if it's actually monitoring the tanks through the separator. So he senses that the separator is basically the tanks and not the cargo tanks itself. So I term it as a deceiver. So there you go. Put in your comments, and if not, kindly subscribe and click the like button if it pleases me. Thank you.